This old tank has been going since 2006, and it's 21 now, so what, 15 years this winter. This is one of the original central boilers. It's the 5036. You see right there when it was made. That's the year I got it. This is one of the good boilers. It just has the heat baffles in the top, rippled baffles, and a big baffle in the back before it goes down and out the chimney. Turn the flashlight on, maybe we can see something. There we go. And there's the big baffle in the back. So all your hot gases get trapped up in there, help heat your water. You get ripples in the top. Nowadays you gotta have all this catalytic converter, gasifier crap and junk like that on to keep the EPA happy. So I'm gonna fire this thing up today. Nights are getting colder and I got plenty of firewood and we can save some propane. This is the original water tube on it. It's kind of dirty. I tried to clean it out last year and still dirty. I can see the water level if I hold the flashlight up to it. I don't know if we can get it on the camera real good, but that cold. It's right about here right now. It's about halfway up from the full range. So I'm not going to fill it right now because the water's cold, and as we all should know, when water gets hot it expands. So after the water is up to temperature, we'll check the level of it and see what we've got. If we fill it right to the rim right now, then we heat it up, we're going to be blowing out the top up there on the vent. So right now it's all powered down. This boiler has eaten a lot of wood in the last 15 years, and it will eat about anything. I don't burn green, I don't burn chemical wood, no pressure treated, no paint, no plywood, nothing like that. This is the controller, the brain. I have two pumps in this one. One goes to the house and the other one goes to the garage. Everything's underground. In the off season, I shut these valves off. So for first firing up, we're gonna turn on the valves. So those are the supply valves from the pump. And return valves. That one goes down. There we go. Everything is open and ready to go now. Now we can turn it on. Pump's turned on. Draft door just opened. That's what the clunk was. Jacket water temp is 51 degrees. So the reason I close these valves in the off season is because if there is a little bit of a pinhole leak somewhere, you're going to lose basically what would be called your prime, and then you got to get all your water, any air back out of your system. This is an atmospheric pressure system. It's not pressurized anywhere. So even in the house, in the hot water baseboard, in the shop, everything is atmospheric pressure. It's not 12 psi or whatever your normal baseboard pressure runs, like an oil furnace. There's a little charge of air that just came out right there. Heard the gurgle. So I'm gonna cheat a little bit and use my propane torch. This is my trash wood pile. Those are clean 2x4s. This is just some junk wood I want to get rid of this year, because if I don't get rid of it this year, it's not going to be any good by next year. Stuff like that, starting to rot out, starting to get some shrooms on it. So get rid of this first before the real wood comes along. Oh, come on, you stupid piece of junk. Oh, it worked before I turned the camera on. Alright, I have to go get a sparker, I guess. Alright, we're in business now. Got some good clean scrap wood in there. Good and dry. So another nice thing with having this thing outside is I don't have to carry the wood inside, don't have all the wood dust inside. Don't have to worry about chimney fire in the house. There's some smoke rolling back out, that's okay. And with that big door, this thing will eat some decent size pieces of wood. You don't have to split it up into little itty bitty pieces. On average, if these are split because they were bigger, like that one is, like this one is, anything like that, it's 2 feet long. This is some popple. Even if that was a whole piece, obviously it's going to fit in the door, but it's popple, so I always split popple and birch so it doesn't start punking out on me. That boiler will eat a 3-foot long stick, no problem. Plus I can throw in junk like this, you know, stumps, fill it up full of that, whatever. She'll eat it, no problem. It's not fussy. So see, there's a lot of prep time on the wood. I mean, granted, you can bust it down to 16-inch if you want, but that's just a lot more work. Yeah, you can start to get rolling down a little bit more. Basically, the way this thing works, it's pretty simple. If I pull this panel out right here, inside there is a little brass slug about yay long, little round tube that goes inside the water jacket. There's a recessed hole that slides in there. And it's a sensor wire, it's a temperature sensor. It's a sensor head, and that's what this wire right here is. Leads up and goes into that, so it gets up inside to the water jacket. Then that wire just comes down, goes up inside behind this panel, comes over to this control head. And then on the control head is where I program what I want the draft door to open or close at, whichever way it goes. I think it's what I want it to close at. So if I want it to maintain a temperature of 185 to 195 degrees here, I'll set this to close at 195 degrees. So when this goes to 195, the door closes. When it falls down to 185, the door opens up. There we go, we're ripping good now. We can turn the torch off. Don't want to use gas, don't want to use oil, diesel, nothing like that. Getting this thing going. Maybe a little paper in there or something if you need to get the wood going. Got a good dog on there. I'm going to replace the gasket on this thing pretty soon. This is something I did a while ago to cheat with. Made some hinges. These are paddle lock hasps because every once in a while you get some creosote and crap in here. Start making things bind up and stick. Not very often, but sometimes. And it's getting to be a real pain having to keep taking these screws out to take this whole panel off to clean it up. So, some cheap hinges, I had those on hand. And brazed them on. So the top half screwed on. I cut that in half with a Sawzall. So now we got the hinge door. Get that in here. Way up in there, you can kind of see, there it is. That's a electric solenoid. That's what the brain controls. It's an electromagnet. And that makes this thing open and close, up and down. So when we gotta heat the water up, it opens up like this, and then when it says, okay, I'm up to temperature, it shuts the power off to it and it drops down. So that's how it regulates it. This boiler has no problem heating a 24 by 36 shop and a 24 by 36 house. It does it. Hopefully I get another 15 years out of it. So in the shop, the wood boiler is also heating hot water. It kind of looks like a mess in here. It's a shop. So I wasn't really too worried about cosmetics. This old water tank, it's an electric water heater. It's not hooked up. I mean, you can see right there, the element, the upper element, doesn't even have wires. There's no thermostat, no controller. Bottom, same thing. The only thing the tank is doing is holding water. So this black tube, this green line comes in from the boiler. This black tube is what they call the side arm heat exchanger. And it's got an outer shell, then an inner tube. Don't mind this stuff. Was this piece right here? This used to be in a hot water system heating a building through baseboard. That's what this stuff did with the zone valve. So when I put it in the shop, I didn't bother reconfiguring all that. I just capped it off there because we didn't need it. That's running through on the bypass so they can circulate. Like I said, I didn't care about cosmetics. It's a shop. So basically the way it works is the water comes in the bottom, comes up through the outer shell, comes up here, out here, and this is boiler water. Inside here, on the inner tube, which has no actual contact with the water on the outer tube, that's your domestic side. It goes up to the top of the water heater. You can kind of see there. And it connects down in the bottom. You get a pipe coming out of the bottom of the water heater. That valve, you can see right down there, there's a boiler drain valve. If you take a hose, connect that, and connect this valve, that connects the inner jacket to the outer jacket, so you can fill the wood, the wood boiler with water. I have them capped off just in case I accidentally hit the valve with something. I don't have a 195-degree water come flying out of this thing. So in the shop in the winter time, I'm spoiled. I've got hot water in the sink. That's pretty nice. Try to crawl through this mess in here. So let's go up. Putting this in here was an afterthought. I've got a propane tree up there. The thermopex is coming in through the wall there. It's not coming in through the floor, unfortunately. I had to put that little stub there with the valve in it as a bleeder. Had a hell of a time dealing with that, trying to get the air out of this system. But way up there, that's a propane heater for backup. Way up there is a hot water heater. So the jacket water goes up, goes in the bottom of that, circulates up through the fins, comes out the top, comes back down, goes out through. I've got a lower bleeder valve out through there and back out to the boiler. So that's a cycle for the shop. These other pipes here are the domestic side, like that one there with the valve, and that white one, cold and hot, leading out to the back of the shop, going that way for the sink and for the toilet. So the wood boiler heats the buildings and makes hot water out here. It also makes hot water in the house. I'll show you how that works too. This is not as pretty as I wanted. Not nearly as pretty as I wanted. Had to put the line in underneath the house after the house was built. So I actually had to drill the cement out, dig outside underneath the footing, get the thermopex under the footing up through, which is what you see right there. And yeah, that was a good time. This house is nowhere near finished. I'm still looking at 2x4s, floor stringers, insulation. Materials are expensive these days, but at least it's warm and dry. So here's the gist of how it works. You can see where it comes in right there. I filled it back in with cement, obviously. So this is a supply line marked with black strip, so I know what it is on the other end. And here's this contraption. This is what makes all of the domestic hot water for the house. I mentioned the house is only 24 by 36. That's a very small house. This room I'm in now is only 4 feet by 4 feet. So it's pretty tight. So the water comes in right here. It goes through this heat exchanger. It comes out here. Hits a zone valve, which is controlled by a thermostat, ordinary household thermostat. Then it goes back out through this green line, where that PEX, back down to there, and out to the boiler. That is the circulation circuit if the house is not calling for heat. That's always circulating. I didn't mention out in the shop, but that green line that I pointed out there always circulates 24/7. Just like this one, it never stops. So when the house calls for heat, this will redirect the flow and open up. So then the water pushes out through here, goes out through these two lines, goes upstairs, goes downstairs. Goes out, makes its loop, comes back. Here's the return lines in the rear. Comes back through this valve. Then it goes out to the boiler. This line right here is hooked into the domestic water line. Here's a check valve. So if the boiler is low and needs water, all I have to do is turn on a valve on the other end of this, and it'll just push water into the return line and into the system. It's just that simple. When the boiler is not in use, we've got an on-demand gas water heater. So there's plumbing running into that, and all I gotta do is just switch a couple valves to change between this and that. So it's real easy. It's just a couple valves, switch between the gas and switch between the wood boiler. So unfortunately it's not pretty, but it works. Oh, I forgot to mention that. That's a tempering valve. Also have one of those out in the shop on the domestic side. That prevents you from getting 195-degree water landing in your shower or in your sink. It's got a dial gauge on it. You can set your temperature to like 120 to 165 degrees, something like that. Turns back and forth. And what that does is it mixes cold water with hot water right there. And this is the hot water line. It goes out domestically to your house. So you wouldn't think that this little box, you pinch it in your fingers, and it's only 12 inches long maybe. And I can span my fingers across it this way. You wouldn't think that that thing would make hot water. I was skeptical the first time I ever used it. When you get in the shower, it never goes cold. It'll stay nice and hot and toasty. Somebody else can draw hot water in the house and shower is still nice and hot and toasty. So for what it's worth on its size, it works pretty good. I'm impressed with it. Alright, I've come back just a little while later. Just hit 140. Have a little fire going. She's good and hot in there now. Throw a few more pieces in. So we're getting up to temperature. It's circulating all right. Grabbing onto my return line from the shop and return line from the house. They're both hot. So that means the water is getting through the system. I just heard a clunk. Damper door just closed at 185. I couldn't remember what I had this thing set to. So, yep, at 185, this will close the door, and at 175, it opens the door. So, right now, she's closed.